Hey guys, this is Mr. Sal. I'm gone for the day. Of course, you guys are going to need the green sheet for this classwork. But take a minute. If you haven't grabbed the green sheet, do that. But if you need a calculator, grab one. Be nice to the sub and take a minute and do this bell work. All right, 1 minute, go. All right, there's the answers to those. We're not going to have time to go over those today, so you can check your answers with how you did on those. But yeah, each one of those is correct. They would make the original equation a true statement. All right, here's our two objectives. I can solve multi-step linear equations that have one solution, infinitely many solutions, and no solutions. I can identify and provide examples of equations that have one solution, infinite many solutions, or no solutions. So take a minute and copy these two down. Go. All right, that was a good minute, so we're going to go ahead and get started on the worksheet now. So you guys have had lots of practice with solving equations, you guys. So just remember, a solution to an equation is where we replace the variables with some number that would then make it a true statement, okay? We've had a lot of practice with this. Last time we learned about how to do this with fractions and decimals that are in the equation. We've always found answers that are fractions or decimals, which is fine. So we should be able to operate on these using principles of equality no matter what. Okay, but take a minute and just see if you guys can solve these two. Okay, we will give you, well, actually this one will give you about a minute. Take a minute, solve these two for x, go. All right, let's go ahead and do these two together. So we'll start with this one, and we'll just keep applying the same principles as we have. And so for me, I'm going to put the x's on the left and the numbers on the right, just like we usually do, which means that this -1 right here term needs to go away. I can't have it there on the x side of things. So I'm going to add 1 to both sides. Okay, that's pretty good. -1 plus 1 is 0. We'll drop this x right here. Drop this one as well. That's equals. And 1 plus 1 is 2. All right. Now, some of you guys look at this and like, oh, I know something funny is going on right here. Well, let's find out for sure what's going on. See that plus 2, it's on the number side, but this x is on the number side as well. We can't have that on the number side. So we got to zero this one out as well. So I'm just going to subtract x from both sides like this. And what happens? Well, this does zero out. That's fine. We'll drop the positive 2. But what happens to the left side? It's zeroed out as well. However, incidentally, as that may have happened, we have now 0 equals 2. Remember, we're trying to find values of x that make this true, but it resulted in an untrue statement. Right? We need to understand that 0 equals 2 is not true. Or more specifically, it's false. Well, since it's false, it's not true, then what this means is that we've encountered a situation where we just have a number that doesn't equal number. That tells us we have no solutions, right? And if you remember, as part of our objective, that's one of our objectives, is knowing when equations result in no solutions, all right? And we'll discuss this a little bit more later on in the lesson. But let's look at the other side of this. So on this one, we got 5x minus 10 equals 10 minus 5x. Now this one actually is not a special scenario at all. Let's go ahead and continue solving this one, okay? So I'm going to put the x's on the left and the numbers on the right. So the 5x is going to stay. That's good. But the minus 10, nope, no good. I got to add 10 to both sides on this one, which will zero that out. I'll drop the 5x there. That's good. This equals 10 plus 10, which is 20, and I'll drop this negative 5x as well. Well, now this negative 5x is on the wrong side of the equal sign. It's on the number side of things, so I'm going to have to zero that out as well. Let's add 5x to both sides. Okay, so we can see pretty quickly that this is going to result in not a very unique scenario, but a scenario nonetheless. 5x plus 5x is 10x. We'll drop the 20 in the 5x's, and negative 5x zeroes out. Well, the last thing I want is a 10x. I'd rather have a 1x instead. So just take the 10 and divide it by itself. And that will tell us what x is. Okay, so x is equal to 2, and that's pretty good. Let's just double check by plugging it back up in here into the equation. 5 times 2 is 10 minus 10, that's 0 on the left side. 10 minus 5 times 2 is 10. 10 minus 10 is 0. 0 does equal 0. Now notice this is when we're checking that we get 0 equals 0. That's going to be important to remember. And that confirms that our answer actually is 2. It made the original equation a true statement. But we're going to see 0 equals 0 in some of these future problems, which is going to be produced in a different scenario. It's kind of rare for us to see checking where 0 equals 0. Usually it's like 21 equals 21. So in these types of cases, it's okay, but we're going to see this a little bit differently here in just a sec. All right, let's go ahead and get these two done. We'll do these together, and then we'll give you a chance to try the next couple. So number 3, we're going to go ahead and solve this like we would a regular equation, not knowing if the answer is going to have infinite no solutions or one solution. So we'll start with distribution, and that's 4 groups of m, which is 4 m's, and also 4 groups of -3, which is -12. Well, this should equal 10m, and then we're distributing -6 on this, so it's -6 groups of m, which is -6m, but also -6 groups of 2, which is -12. Then we'd look for any like terms we can combine. Well, we got the m's right there. 10m minus 6m is 4m. So now we got 4m minus 12 equals 4m minus 12. And again, some of you guys are like, well, something fishy is going on right here. I got 4m minus 12 equals 4m minus 12. Let's continue, and then we'll explain exactly what is going on. Okay, so I'm going to put my m's on the left, numbers on the right. Okay, so the 4m stays, but this negative 12 right here has got to go. I'm going to add 12 to both sides, which is going to zero it out. So I'll drop my 4m. That's okay. It's going to equal the other 4m dropped. But what happened here when we did negative 12 plus 12 as well, that's zeros out as well. So I have 4m equals 4m. Now some of you guys are like, dude, that's a true statement. I know it right now. That's okay, just we're going to interpret that in a moment. Well, I want the m's on the left, and that 4m in purple is on the wrong side, so I am going to zero that out by subtracting 4m from both sides. Well, this is where things hopefully kind of become a little bit more relevant, because 4m minus 4m is 0. But it happens on both sides, which means we got 0 equals 0. Well, just going back to what we talked about on that last slide, is this was true. This is from number 1, right? That's true, but it's always true, in fact, that 0 does equal 0. Okay? So since it's always true, what this means is that, see, we eliminated the m's here, and we just have a number equals a number, which is true in this case. But since it's always true, it means that if we went back to this equation, it wouldn't matter what value we replaced m with, it's always going to be true. So you may get different values like 2 equals 2, whatever. But you could replace m with an infinite number of values and it would still be true, which means this one has infinite solutions. And that's actually the answer we're looking for on this one. So let's see how we do on a problem like this. Okay, so I'm going to do the distribution here. That's 4 groups of x, which is 4 x's, but also 4 groups of negative 4, which is negative 16. And it still equals the 4x minus 16. Well, going back, this is a pretty good way to tell that we kind of have a match, right? Like over here, we had 4m minus 12 equals 4m minus 12. That's a true statement always, because one side is the same as the other side. This one, the blue, is matching the black right there. Now we could continue this, and I'm going to, but if you said, you know what, I see that the two sides match, therefore we have infinite solutions, bam, you'd be done, okay? But let's just emphasize this, because if we can get down to where it shows 0 equals 0, we're still in good shape. So I'm going to put my x's on the left and the numbers on the right, which means I got to get rid of that negative 16, so add 16 to both sides. And we see the same thing going on. We canceled out both of those negative 16s. So I am going to drop my 4x there. And this should equal the other 4x dropped. And again, if you didn't notice before, you see that they match right there also. But, you know, again, I'm going to subtract this 4x. But I got to do it to both sides. So that zeroes out and that zeroes out. So we end up with 0 equals 0, just like we thought we would. Therefore, this is infinite solutions. Now, if you think about what we saw on number 1, where it was, I don't know, 0 equals not 0. Okay, as soon as you see 0 equals something else, then automatically you would have no solutions. Okay, so there's not really too big of a difference between infinite solutions and no solutions. You're going to see the x's cancel out in both situations. It's just in one case you get 0 equals 0, and the other you'll get 0 equals something not 0. So this next slide is telling us how we can tell pretty early on if there's one solution, infinite solutions, or no solutions. And there's another way to look at this. One solutions. If you ever have one solution, on either side of the equal sign, you're going to get different number of x's. So your coefficients of x's will be different. Like if you had 3x plus, what, it doesn't even matter, but it equaled 4x plus 8 like this. Well, because the coefficients are different, 3x and 4x, and this would be fully simplified, by the way, as soon as they're different, then automatically you're going to get one solution. For infinite solutions, you may have the same coefficient of x, right? Like maybe on one side of the equal sign you got 5x, but on the other side you got 5x as well. And again, this is fully simplified. But infinite solutions is where you have the same coefficient of x on both sides of the equal sign, but then you'd have to add the same thing. So maybe you add 9 to these, okay? And again, this shows a match, which eventually means that you're going to end up with 0 equals 0. Okay, so that's what it's showing by a equals a right there. On the other hand, if you saw something like the coefficients match, like 2x and 2x, but then they're adding or subtracting different things, so maybe it says, you know what, plus 8 right there, and then over here minus 7. Well, now even though the coefficients of x match, but you're adding or subtracting different things, well, now this is a no solution scenario. Okay? So that's a pretty quick way to tell if there are one solutions, infinite solutions, or no solutions. So these ones, you know, it's going to take a little bit of work to get through these, but I'm going to take a little bit of a shortcut. If we see that there's infinite solutions or no solutions, then we're going to declare that there is. If there's one solution, we'll figure out what it is. So again, this is, we can tell after it's been distributed and simplified if it needs to be. So 2 groups of x is 2x, and 2 groups of negative 5 is negative 10. Well, this gives us 2x minus 5 equals 2x minus 10. Well, the 2x's match, that's okay, but see how this one's minus 5, but this one's minus 10? Since the x's are the same, but we're adding or subtracting something different, automatically this one ends up as a no solution problem. Now if you continued solving that, that'd be fine. You'd end up with like 0 equals, I guess negative 5. Maybe 5 equals 0, something like that, depending on how you solved it. So what about number 6? Well, the coefficients of x's match on either side of the equal sign, but again, this is that's a minus 4 right here. Over here on this one, you could say it's a plus 0. So they're adding different things, which means that this one also has no solutions. But just once again, if you had solved that completely, you would have found that it was 0 equals negative 4, which is a false statement. In fact, this one was false as well. Both of these are false. They're always false, so there's never a solution. Alright, so now that you guys have seen that, we kind of talked about it a little bit. See if you guys can figure out if these ones have infinite or no solutions, and if there's one solution, figure out what it is. Alright, I'm going to give you 1 minute on that. 1 minute, go. Alright, let's go ahead and get started on number 7. Well, solving this as usual, I'd be looking to distribute first. So 5 groups of 2 would be 10, and then 5 groups of v is positive 5 v's. The rest of it we didn't touch yet. Okay, so we got 3v plus 5 plus 2v equals 10 plus 5v. And next we'll combine any like terms we have, which we do. 3v's and 2v's is 5v's. Then we got that plus 5 right there, which equals now 10 plus 5v. Well, going back, we don't need to go any further than this, you guys. We got same coefficients of v's on both sides after it's been simplified, but here I got plus 5, and then over here we're adding 10 right there. Okay, so they are different, so this one shows no solutions. And again, if you had finished solving it, you would have found 0 equals 5, which is definitely false. So what about number 8 right here? We've got to be careful on this one a little bit. This is a negative 1 right here that we're going to be distributing into the parentheses. So negative 1 group of 4a would be negative 4a's. And negative 1 group of 8 would be negative 8 right there. So as of right now, we got 5 minus 4a minus 8 equals 5 minus 4a minus 8. Now, just so you understand, if you know that there's infinite solutions right now, boom, you're done. Because the two sides of the equal sign match exactly. But let's say we didn't notice that and we wanted to combine like terms, right? So 5 minus 8 would be negative 3. Still got that negative 4a. And then this is going to equal, on the other side as well, 5 minus 8, still negative 3, guys. But again, we still got that negative 4a. Well, now they still match exactly. But to emphasize this, we have a coefficient of a that's negative 4. And we got a negative 3 that's tacked onto that as well. Okay, so since both sides do match, this one has infinite solutions. All right, for number 9, we're going to do this a little bit different. What I'd really like to do is get rid of that fraction business, so I'm going to multiply both sides by 2, just like we kind of would for a proportion. So that cancels out the 2's, and I've got 2x plus 8 equals, in fact, I'll do the distribution now, that's 2x plus 8. Well, the coefficients of x are the same, and we're adding the same thing in both places. So this one is infinite solutions. And then what about number 10? Well, we can distribute this one also, the 1/3 into the parentheses. 1/3 times 1x would be 1/3 of an x. And 1/3 times 2 would be, well, negative 2 would be negative 2/3. Well, what's the difference between that and x thirds minus 2/3? So we see that we got our negative 2/3 on both of these, but just so you understand, this x over 3 is also written as 1/3 x. So the full equation would look something like this. 1/3 x minus 2/3 equals 1/3 x minus 2/3. And again, we see the coefficients of x are the same as 1/3, and we're also subtracting the same thing from both sides. So this one also has infinite solutions. All right, let's go ahead and take a look at these two. So number 11, we do have some distribution on this one. And 2 groups of 3a's would be 6a's. And 2 groups of negative 12 would be negative 24. It's going to equal, on the other side, 3 groups of 2a's, which is 6a's. And 3 groups of negative 8 is negative 24. Well, here again we have matching expressions on either side of the equal sign, so automatically we know that there are infinite solutions. All right, so we got 3x minus 12 over 3. This is pretty much the same as that last one. We're going to multiply both sides by 3, and we do need parentheses on the right side. That cancels out into a phantom 1. So we're left with 3x minus 12 equals, we need to distribute this 3x plus 12. Now that's different, right? We got the same coefficients of x, that's fine. But since this one is subtracting 12 and this one is adding 12, they are different, which means that though the coefficients are the same, this one has exactly no solutions. So what do we do with number 13, which is really just a proportion? Well, we're going to use cross multiplication on this, right? So it's 2 times the 2x plus 2, and then the other cross as well, which is 4 times the x plus 1. Well, these are equal, or they should be equal, if it's proportional anyways. And now we'll distribute the 2 into the parentheses. So 2 groups of 2x would be 4x's, and 2 groups of 2 would be positive 4 right there. Does this equal the other side? Well, that's 4 groups of x, which is 4x, and 4 groups of 1, which is positive 4. Again, we got the matching x's, 4x and 4x, but this one adds 4, this one adds 4 as well, so this one also has infinite solutions. Alright, for this one, you could split the x plus 1 all over 5 into 2 fractions, which may make a little bit more sense, but we're going to have to solve this one because there's one solution. Here's y. If I multiply both sides by 5, right, I multiply this side by 5, kind of like we would with proportion, that's going to make that a phantom 1, so I got x plus 1 here, and then we can distribute the 5. 5 groups of x is 5x, and 5 groups of 1/5 is 1. Well, now we see that this coefficient of x is 5, this coefficient of x is a phantom 1. They're different, which means we're going to have one solution. So in this case, I need to put my x's on the left and the numbers on the right. So I'm going to get rid of that plus 1 by subtracting 1 from both sides. So that does zero that out. I've got 5x now equals x. And this zeroes out as well, which is fine, because we can still subtract that 1x from both sides, right? So even though that zeroes out, 5x minus 1x is 4x. But we need to show what this equals, so instead of it being a phantom 0, we're just going to show 0. And continuing with this, we're going to have to divide both sides by 4. So then x equals 0 divided by 4 is 0, and that would be the solution for this problem. And you could check, right? You could say, well, what if I replace the x's with 0? Well, you'd get 1/5 equals 1/5, which is a true statement. All right, let's check number 15 then. So on this one, we need to distribute that 1/2 into the parentheses. 1/2 of an x is a half of an x, and half of a -8 is -4. Now that x over 2, I'm going to write it as 1/2 x so we can see exactly what that coefficient is. And we see that the coefficients of x match. We also have -4 and -4, which also match, which means this one has infinite solutions. So take a look at this one, see if you can find 3 different expressions that would result in infinite solutions for this one. All right, we're going to give you guys 1 minute to try this one out. 1 minute, go. Alright, so on this one we wanted infinite solutions, which means that if you had taken the 4a minus 12 and just set it equal to, well, 4a minus 12, that would have worked. Well, what if you had 4a minus 12? What's something else you could have had? Well, anything that adds up to 4a's. So something like, I don't know, 3a plus a, and then, of course, subtract your 12 there. That would work as well. But you could split up the 12 as well. So 4a minus 12 equals, again, you can keep your 4a right there, but just split up the -12, maybe like minus 10 and then minus 2. Okay, it doesn't have to be super complicated on these. All right, let's do this one together. So we need no solutions on this one, right? We're comparing this all with x plus 1 on this stuff. So it needs to be equal. This would be the equation part of it. It would have to equal to something that has an x, but we need to add something different, like 2. Right? Maybe you want to add, I don't know, even 0 right there. Maybe even make it a phantom 0, but you know, if you wanted to be a little creative and say, you know what, I'm going to subtract something and maybe even make it a fraction like 1/4. Still, this one would have no solutions because the x's match on both sides of the equal sign. But here where you add 1, as soon as you add something different, automatically no solutions. All right, and just looking back, if we wanted one solution, no matter what, all we need is different coefficients on, sorry, I'll say that again, different coefficients on both sides of the equal sign. So I don't really care about the plus 6 in this case. I'm just looking at the coefficient of 2 right there. As soon as I have something different, even if it was just 1x, even if it was 0x, right? So maybe just make that equal 0, doesn't matter. Or, well, anything else like a negative 3x. All of this works. And then if you, again, felt a little bit creative, you could add something to it. You could subtract something to it. It's not going to matter. As long as the coefficients are different on both sides of the equal sign, you'll have one solution. All right, so that brings us to the objective again. Hopefully you guys felt pretty good about solving these, especially when you see that there's infinite, no, or one solution, because it's going to be on the test, okay? And that's coming up pretty quick because I think we got one more section, then the review, and then the test. Okay, so be ready, that's coming up. Thanks, you guys. Hope you've been good for the sub. Completed the worksheet. If there's any time left in class and the sub can decide, take a computer, go get started on assignment. Hopefully you can get it done. If not, you'll have to complete it somewhere else, and we'll see you guys next time.